Hello dear students, welcome to the 9th lecture of class 12 physics, first chapter electrostatic electric charges and fields. In this lecture we will be discussing electric dipole. The outline of the uh, video is like this. First I will discuss the definition of the electric dipole, then we will define a physical quantity which is called the electric dipole moment. Then we will do a numerical problem before concluding the lecture. First, what is an electric dipole? In the last lecture, we studied electric field lines and their properties. Okay, in this lecture, we are studying electric dipole. Uh, as the name implies, you can see dipole means there are two poles. Which are the two poles in electrostatics? They are the positive pole and negative pole. Okay, so there are two poles. Electric dipole means there are two poles. One is positive pole and the other is a negative pole. Okay, so what is an electric dipole? Electric dipole consists of two equal and opposite charges, separated by a small distance. Okay, so two equal and opposite charges separated by a small distance is called an electric dipole. So there is a plus q charge and there is a minus q charge which are separated by a small distance. This distance is very small. I am representing this distance by 2a. That is to simplify. You can represent it by a also, or a d also, no problem. But this 2a representation is used to simplify the some derivations which are coming in the next lectures. Okay, so it is better to represent the length by 2a. Okay, so what is an electric dipole? Electric dipole consists of two charges. One is a positive charge and the other is a negative charge. So we say like this: two equal and opposite charges. Equal means the magnitude of the charges are the same. Opposite means their signs are opposite. One is plus charge and the other is the minus charge. Okay, so this is an electric dipole. Dipole means two poles. Okay, so this is an electric dipole. So you got the definition of electric dipole. Two equal and opposite charges separated by a very small distance is called an electric dipole. Okay, now we will move to a physical quantity which represents the strength of this dipole. Okay, to represent the strength of the dipole, we use a physical quantity that is called electric dipole moment. Electric dipole moment. Actually, the electric dipole moment is the product of charge and magnitude of the charge and length of the dipole. So electric dipole moment is the product of charge. Charge means the magnitude of the charges. One charge is plus q and the other charge is minus q. We are taking the magnitude of the charges. The magnitude is q. Okay, and this q should be multiplied with the length of the dipole. Then you will get the physical quantity, uh, electric dipole moment. So this is the magnitude of electric dipole moment. It is represented by the small letter p. Dipole moment is represented by the electric dipole moment is represented by the small letter p. Okay, so this p represents what? Electric dipole moment. It's a product of magnitude of the charge and the length of the dipole. Okay, this is the definition of electric dipole. You can read the definition here. Electric dipole moment is defined as the product of magnitude of one of the charges and length of the dipole. Magnitude of both the charges are equal. So p is equal to q into a. But this is a vector quantity. Electric dipole moment is a vector quantity. Here I represented dipole moment as q into 2a. But when we write it in vector form, we have to write like this. On the right hand side, to represent its direction, we use this unit vector. The cap represents a unit vector. Now, what is the direction of this unit vector? Or what is the direction of the dipole moment? As I told you, this is a vector quantity, and it can be represented like this. Q into 2a into, this is the magnitude of this quantity, and p cap represents the direction. Okay, so what is the direction of electric dipole moment? Electric dipole moment. In electric dipole moment, there is a positive charge as well as a negative charge, minus q charge. The direction of electric dipole moment is from the negative charge to the positive charge. This is the direction of electric dipole moment, that p cap vector. That p cap vector is from negative to positive. we have studied in the previous lecture that an electric field will be starting at a positive charge and ending at a negative charge. Suppose there are two charges, plus q and minus q. In that case, the electric field will be starting at the positive charge and ending at the negative charge. So the direction of electric field is from positive charge to negative charge. But in the case of dipole moment, the direction is from the negative charge to the positive charge, from the negative charge and to the positive charge. So the dipole moment, the direction of dipole moment is opposite to that of electric field. Okay, so the direction of electric field, read this sentence: the direction of electric dipole moment is from the negative charge to the positive charge. Okay, now we will do a problem. Read this problem. A system has two charges. One is this 2.5 into 10 raised to minus 7 coulomb, and the other one is minus 2.5 10 raised to minus 7 coulomb. As you can see, one charge is 2.5 10 raised to minus 7 coulomb, and the other charge is minus 2.5 10 raised to minus 7 coulomb. That means they are equal and opposite, or they constitute a dipole. And these are located at 2 points, A and B, on the coordinate system. Okay, so what is this point? A 0 0 minus 15. The QA charge is located at this point, and QB charge is located at the point B. Now we have to find the total charge and the electric dipole moment of the system. Total charge and the electric dipole moment of the system. Let us solve the question. You can see that the 2 points, notice the 2 points. A is this point and B is the point 0 0 plus 15 centimeter. By this representation, this is a three-dimensional representation. You know, this is the x coordinate, this is the y coordinate, this is the z coordinate, and here this is the x coordinate, y, z coordinate. Or I can represent like the x1, y1, z1, and is x2, y2, z2. So it is very clear that the in both a and b, the x coordinate and y coordinate both are 0. So what are the locations of the charges? Think about the location of the charges. On which axis are the charges located? Which is the axis on which charges are located? You can see that the charges are located on the z axis. Z axis, because x and y are 0. Both x and y are 0 on z axis only. Okay, so consider the z axis. I'm drawing the z axis like this. If there is only one axis, you can draw it in any direction, no problem. Here I'm not considering x or y, so I am drawing the z axis like this. This is plus z, and this is 0, and this is minus z. That will be like this. Okay, so here the z2 or the b point b is plus 15 centimeter away from the origin. Okay, the point b is this point 15 centimeter away from the origin on the z axis, and the point a is minus 15 centimeter. Yeah, like minus 50 means 15 centimeter to the left of the origin. Okay, so this is the point a. Okay, on the points are on the z axis because x and y are 0, and z1 is to the left of origin uh, at a distance of 15 centimeter, and the point b is to the right of origin at a distance of 15 centimeter. So what is the distance between the 2 points? 15 plus 15, totally it is 30 centimeter, right? 30. So this is the, actually, you know, the first charge is placed here. The QA is here and QB is here. Both the charges are equal in magnitude. You can see that uh, this is the positive charge and the other one is a negative charge. This is the negative charge. This is the positive charge. Okay, you can see the sign here. This is 2.5 and this is minus 2.5. Okay, so you got the magnitude of the charges. So the magnitude of QA and QB are equal. What is the magnitude? Magnitude of the charges. What is the magnitude? 2.5 into 10 raised to minus 7, that coulomb. Then what is the distance between the two charges, or the length of the dipole? It is 30 centimeter. You can convert it into the SI unit, because the charge is in the SI unit. So you have to convert the distance also into the SI unit. So you will get 30 centimeter is, you can divide by 100, or you can multiply by 10 raised to minus 2. So you will get 0.3 centimeter, 0.3 meter, sorry. This is in meter. When we divide it with 100, it is in meter. 0.3 meters, 0.3 meters. So what is the, now the question, what are the total charge? Total charge and electric dipole. Total charge is, total charge. You can see the total charge is the sum of the two charges, QA plus QB. One is minus 2.5 into 10 raised to minus 7. The other is 2.5 into 10 raised to minus 7. Okay, QA is plus and this is minus anyway, no problem. So the answer is 0. Total charge is 0. Okay, so the first answer is okay. Total charge is 0. Then the electric dipole moment. What is the electric dipole moment? What is the electric dipole moment? Electric dipole moment is electric dipole moment. P is equal to Q into 2A. Q is the charge. Magnitude of the charge is 2.5 into 10 raised to minus 7. Into length is 30 centimeter or 0.3 meter. Okay, we got it. 0.3 meters. So when you multiply, you will get the answer. Actually, the answer will be 2 into 3, 3 into 2.5 will be 7.5, and there is a decimal place, so it will be 0.75 into 10 raised to minus 7 coulomb meter. This will be the answer. Okay. I didn't say about the unit of dipole moment. What is the unit of dipole moment? You can simply see that dipole moment is charge times length. So it is coulomb times meter. Okay. Don't read as centimeter. It is coulomb times meter. Coulomb meter. Coulomb into meter. Coulomb meter. This is capital letter C, not small letter c. For centimeter, you write small letter c. Coulomb meter. Coulomb meter is the SI unit of electric dipole moment. So, uh, you got an idea about what is electric dipole moment. Electric dipole moment means two equal and opposite charges separated by a very small distance. And the definition of a dipole moment, what is dipole moment? It is a product of one of the charges and length of the dipole. Dipole moment is you understood that dipole moment is a vector quantity. And what is its direction? Its direction is from the negative charge to the positive charge. Negative charge to the positive charge. And what is the unit of dipole moment? It is coulomb meter. Coulomb meter. Okay. Then we did this problem, how to calculate the dipole moment and net charge. Net charge is always 0 for a dipole. There is no need to calculate. If it is a dipole, the net charge is 0, because one charge is plus q and the other charge is minus q. So the net charge should be 0. And what about the dipole moment? Dipole moment, we can calculate using the formula q into 2a to calculate the distance. Suppose in this case, uh, we we understood that this points are on z-axis. Otherwise, you can give you may be given with a general point, like there will be some values here, 1, 2, and here it is minus 3, 4, like that. If there are values for x coordinate and y coordinate, then you can use the distance formula. I think you know the distance formula. To find the 2a, you can use the distance formula, root of x2 minus x1 whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. Using the distance formula, you will get the, yeah, you will get the length of the dipole. Okay, you can, in this case also, if you use the distance formula, this time will be 0, 0 minus 0, this time will be 0, and this is 15 minus 15 the whole square So it is 30 square. 30 square when taken, when we take the root of 30 square, it is 30. So you are getting 30 centimeter. That's right. Okay. So in this case also you can use the formula. Okay. So you can use the distance formula to find the distance between the 2 points uh, at which the charges are placed. Okay. So I'm stopping this video here. We will continue in the next video. Okay, in the next video, I will discuss the torque acting on electrodipole placed in a uniform electric field. Okay, I think you got all the points. Uh, you got a good idea about the dipole, the electric dipole. Okay, thank you.